Okay, so continuing on where we left off, you guys there again? So we're continuing on here. We had a crash from Mastercam 2017 while we were talking about machine definition. So I'm going to load the default mill machine in X9, and we'll go and open the toolpath copy of the machine definition manager. So when the machine definition first came out, the functionality that they built into the machine definition was there for the post writer to use. But there wasn't a lot of work that was done initially up front to hook everything together and make it plug and play. So the structure of the data, how the data is created and captured, is available to you, but the default generic post processors that we've been used to all use technology that is older. So those were developed around the version 9 era of Mastercam, and there was a whole library of posts that had the same basic structure of how it processes data. And now we have this new technology that's coming along for machine definitions to allow us to tell the post processor more information about how our machine functions and be able to pass data to it that we can capture and use. So for pretty much the entire Mastercam X series, there was really only a couple of things that were hooked up by default to the post processor. We've covered one of those things kind of in a couple different ways, but that is the Rotary Axis setting. So there is logic inside the post to capture which axis we are rotating on. And the way that we do it, you see here we've got plus X, we can go to plus Y, plus Z. We could also go to minus X, minus Y, or minus Z. So there's 6 different potential directions when we're talking about a 3-axis coordinate system. So either X, Y, or Z positive or X, Y, or Z negative. And when we use these settings visually in the machine definition manager component page here, so we're editing the component properties, Mastercam will set a numeric value. So it's either going to be 0, 1, 2, 3, or negative 1, 2, 3, or sometimes it's 0 through 5, sometimes it's 1 through 6. Where would we go to find out? For everything like this, where we've got a question about some dialogue and where's that number located, we refer back to the documentation. So when we talk about parameters, a parameter is typically a numeric value, but it could also be a string value. So even if it is numeric in nature, all of the parameters that we're working with internally are stored as string values. So a string value is just a collection of characters, and Mastercam has many functions for dealing with strings. So we can search through strings, we can convert strings, we can do a whole bunch of things using the functions that are built into MP. But we also need to understand that everything that we're looking at on this page. The direction, counterclockwise or clockwise, center of rotation value for X, Y, or Z, defined angle from 0 for the tilt angle. All of these values are stored somewhere internally in the memory. For machine definition values, those are in the 17,000 to 18,000 series of parameters. If we go look at MP fan, and this one's from 2018, so let's go grab the one from X9. So we'll go grab MP fan, and this is just checking, this is the one from X9. Down near the bottom of the default posts from CNC software is all of the parameter definition stuff, all of the calculations. So once we get past all of the output and cut type and can text and all that stuff, drill cycles, then we get down to the parameter read post block section. PPrep, this is the pre-process that runs before we even open up the NC file. So before we've started writing NC data, before we've even started reading NCI data, we call PPrep. This is the first thing that occurs in your post processor. Absolutely first thing. And it is important to understand that when we have these post blocks in Mastercam, that the order in which they are called helps to determine the order in which your NC code is output. So this is the very first post block that gets called when we start processing, and look what's contained inside it. The first line saves a value. So we have save underscore index, SAV underscore INDEX equals index. So whatever the current value of this variable is, we're going to save it. Then we have a line here that has a command variable all by itself. A command variable tells MP to go do something. And in this case, what is this command variable? RD underscore CD $. Command variable calls pMachineInfo to get the control definition parameters. So when we encounter this RDCD on this line here, we are going to go and process all of the parameters that are in the control definition section of the memory map. And when we look at pMachineInfo, machine and control definition parameter capture, this post block gets called continuously for every different parameter number that we are processing. And when I say we are processing, it's because we have to have something that kicks off this call. Now, operation parameters get read through a different structure. Operation parameters get read through PWRTT params if we're talking about the tool table. So this is write parameters during the tool table. And P parameter gets called for all of the operation parameters for every operation we process. So before you process toolpath number 1, we're going to call P parameter for op 1. When we go to process toolpath number 2, we're going to call P parameter for all of the operation parameters for operation 2. When we go to process operation 3, the same thing applies. So we are continually calling P parameter to process all of the parameter numbers for operation parameters. In this particular post, we are only checking two parameter values. 12025 and 2007. But there is also a bit of a difference between the actual parameter values itself. So when we're processing RD_CD, we are calling PMachineInfo for all of the parameters that are between, I think it's 18,000 and 19,000. So you can see here, run the parameter table for the control definition parameters. So what ends up happening is for every parameter that's between 18,000 and 19,000, we actually call PMachineInfo. That's what RD_CD does for us. So remember, we're at the start of the post, we're processing PPrep, and we're calling RD_CD. And what ends up happening is if parameter number is 18,000, it goes to the memory map and it looks starting at 18,000, and then it calls PMachineInfo. So PMachineInfo gets called, and the first thing it encounters is this if condition. And because our parameter is not within this range, so if param code is greater than or equal to 17,000 and parameter code is less than 18,000, if that condition is true, so if both these conditions are true, we are going to call the parameter table. Now, what is a parameter table? I'm going to scroll up just a little bit in the post block, or in the post itself. And you can see that here we've got a section for parameter lookup tables. A lookup table in the MP language is a data structure. It allows us to have a column on the left which provides a key to a variable name on the right. For the machine definition parameters, this particular post has 14 different variables, and the parameter table number is 17,000. So this is parameter table 17,000, and there are 14 different values. So for every one of the machine definition parameters, which is the range between 17 and 18,000, it's actually 17,000 to 17,999, we call this parameter table. So when the parameter table gets called, we look at the column on the left, and if the parameter value is equal to one of these numbers, then we store the value into the variable on the right. For the machine definition, you can see that we're capturing 14 parameters. So if the value is 17391, we're going to store the value in axis_label. If the value is 17397, we're going to store it in SROT_label. If the value is 17401, we're going to store it in Rotary 0. Now that is as a result of if the parameter code is between 17,000 and less than 18,000. Then we call the parameter table and we try to store the value. Now, you'll notice that this if condition can be set to true by up to 999 values, anything between 17,000 and 17,999. So that's what it's saying here. So it says less than 18,000, which is 17,999. So this condition will be true up to 999 times. But even though it's true and we run the parameter table, we're only storing these particular parameter values. So it's important to understand that when we process the parameters, we process all of them. We read through the entire parameter list, we capture the values, and if there's a parameter in the parameter table, we capture the value, we store it in the variable. You can see here, for the control definition, we have the same type of data structure, but we're actually only capturing one value. That's not to say that we can't capture more. We can by increasing the table size, adding new parameter numbers and new variables to capture the values. So what can we capture from the machine and the control definition? All of these options that we see are able to be captured. So that includes everything for the machine components, all of the values that are stored in the general machine parameters. So we can grab the values out of the feed rate limits axis motion tab. We can even grab the string, the location of where our tool database is if we want. The values for our machine dynamics. All of these things are available to us as a parameter. The same thing is true for the control definition. So if I open up the control definition and we go look at the NC output, every one of these options in here is available to us as a specific parameter number, but for the control definition, a lot of these options are also available to us as a predefined variable value. And we would find that info in the documentation. So if we go to the parameter reference PDF, this tells you every single parameter that is output in Mastercam. This one happens to be the version for 2017. And you'll notice it says it's divided into the following sections. New and changed parameters, page 3. Operation and toolpath parameters, page 5. Machine definition, page 160. Control definition, page 226. And machine group parameters, page 272. Traditionally, operation parameters have been numbered 10,000 to 19,999. Recent Mastercam versions have seen this range expand. So X3 introduced the 30,000 series of parameters, which are reserved for use by C-hooks. X4 introduced operation parameters in the 40,000 range. These are no different than the traditional 10,000. Just in this case, they just ran out of numbers. And eventually this range will extend into the 50,000 series of numbers. 2017 began assigning numbers in the range of 60,000 to 64,999 for machine def, and numbers 65,000 through 6,999 are reserved for future control definition stuff. 70 through 75 are reserved for future machine group parameters. So we have these ranges of different parameter numbers that are used to store different pieces of data. And this document, this operation parameter reference guide, shows you which particular number stores which particular piece of data. So throughout these sections, notes and annotations indicate parameters that are only used in previous versions of Mastercam. So as you start working with older posts, or if you've got a post that you've been continually updating, one of the things that changes from, or may change from version to version, is parameter numbers. Now, this can be an issue if you use a lot of parameter read functionality. If we go back to this MP fan example, this is really not a lot of parameters. We're only capturing 14 parameters from the machine definition. We're only capturing one parameter from the control definition, and we're not capturing any from the toolpath group parameters. And what are the toolpath group parameters? If we go back to Mastercam here, the toolpath group parameters come from the machine group properties. So the tool library string, the operation library string, whether or not these checkboxes are turned on. All of this information is saved as a parameter. If we go to the tool settings page, the program number is saved as a parameter. Why is that important? Well, sometimes you may want to be able to look and see if the current program number matches whatever was set in this box. I've also had it where somebody wanted to be able to take a program. So if I go and open up something existing. Oh, let's get something better than this. I know one of these guys has something good in here. There we go. Just wanted something that had a few different operations in it already. So we've got an op here with 29 operations. This is the fixture program, so this is going to be op 1. Right now it shows program 0. Okay. Parameter read program numbers, what we're going to call this. So I'm going to grab the mill. I think this is yeah. Yeah, it's just using mill default. So actually we'll just use MP fan. That'll be fine. So I've got mill default MMD-9 because we're working in X9. One of the things that you'll notice about the default machine definition hooked up to MP fan, it actually uses an A axis, a B axis, a C axis, and this kind of dummy right angle aggregate head component. And the reason that we have all of these different components set in the machine definition is to trick Mastercam into allowing this particular machine to be able to replace any machine definition or any mill machine definition. So Mastercam has logic in it to check the setup of your machine definition. In other words, what is the orientation of your rotary axis components versus the tool planes that are used in your operations. And it checks for compatibility between the two. When it sees that you are trying to replace a machine that maybe doesn't have the same capabilities, it will either give you a series of warnings showing you the operations that are not compatible, or worst case, it won't let you replace the machine at all. And the trick, if that ever happens to you, is to make sure that you have all three rotary axes in your machine definition. Now, just because they're located in your machine definition does not mean you have to include them in the axis combination. So just heads up on that. Now, I think you do have to have at least one axis combination that includes all of them. But you'll notice that we're not including the aggregate, for example. It just has to exist in the component chain. So we're going to take this mill default. We'll do a save as. Okay, parameter read program number. I'll copy that name. Then we're going to go edit the control definition, do a save as. Save it with that same name there. Make a copy of MP fan. Rename it. And then in our control definition, we're going to link a copy of that new post that we just created, that we just renamed. It's parameter read program number. Now, when we add a new post to the control definition, Mastercam in the control definition uses static file paths. This is a really important concept to understand. What it means is that when you link a post in a given location, the settings that you save are only good for that specific file in that specific location. If you move that post processor, the control definition does not use the settings for where that post was located. It goes and uses the default settings for your control type. So one of the most important things that you can do when you are setting up a new post is to set those default settings. Make sure that those settings are saved so that when you upgrade or move your post, that Mastercam will automatically take the correct settings. So I'm going to select the new post that we're going to use. I'll hit save. You'll notice that we now get this green check mark. I'm also going to go back in here and let's do this. We're going to select the default settings. I'm going to go to the tool page. We're going to say, you know what, I want to enable stage tool routines. I'm going to go to my tolerances. Some of the things I typically change in here depends on the machine and the control and what the capabilities are. Modern machines and modern controls generally can use much more precise values. For an older machine, minimum distance between arc endpoints, 5/10,000ths of an inch. That's an incredibly small arc. I'll bump it up a little bit, 3/1000ths. Minimum arc length. If my arc is smaller than 2/1000ths, don't generate it. Anytime you have something lower than the minimum, Mastercam will then break the arc up into small line segments. Minimum arc radius, 1/10. I'm going to go more like 4/10. Maximum arc radius. You really need to know what your machine is actually capable of. Many machines will, limit this. If you're having issues with the large arc, no reason you can't lower those values. Okay? So minimum change in plane for helix. This can be a tricky one, because what this says is how much distance in Z between those endpoints is allowed for us to be able to put out a helix. Right now it's 5/10. Sometimes on some controls I've had to drop that down to 1/10, and other times I've had to bump it up a little bit so that if it was a very small helix, we're not going to allow it, because maybe the control is going to choke on that. So I'll say minimum is 2. Under NC output, we've got sequence numbers turned on. We're going to set the starting sequence to 10. We're going to set the sequence increment here. Well, we'll leave it at 10. But the maximum, we're going to set to 9990, because we're incrementing by 10 anyway. So why not just set it to that? Actually, you know what? We'll set it to, that's fine. Spaces between NC addresses, 1. Now, it doesn't happen very often, but there is an option for an alternate end of block character. So if your end of block character is the $, for example, you can put in the ASCII value equivalent for what you want your end of block character to be, and it will output it. And you can also choose to remove the carriage return line feed at the end of the NC block. So some controls require that as well. Arc settings are contained in the control definition. This is something that we change quite a bit. So what kind of support does your machine have? Does it support only G17 arcs? If that's true, we would turn off support for arcs in the G19 and the G18 plane, XZ and YZ. And what is allowed for helix? A lot of times the default will either be no helix or all planes supported. It's pretty rare for people to actually want to output helical motion in one of these other planes. The only time I've ever done that was with right angle head. So I was using a right angle head with an end mill, and I wanted to be able to, do a helix in G18 or G19. Most of the time, only in XY is preferred. Now, with the arc braking, if you want to allow 300, if your machine will actually output 360 degree arcs, you can turn this switch on, allow 360 degree arcs. If it's not on, then we're going to use one of these braking options. Now, if you've got don't brake arcs turned on, but you do not check allow 360, then it will automatically brake at 180 anyway. So in that case, I recommend you just set brake at 180. Brake at quadrants is safe. The reason it's safe is that it will take all of your arc motion and it will brake it at anything greater than 90 degrees. And most controls have less trouble interpolating an arc that is, if you're going from arc to arc to arc, if it's 90 degrees or less, it's going to be a safer option for you. So we'll get all these things set for what we want. And once we make all those choices, we're now going to save those default settings. So I hit the save button. Now, what we really want, and actually let me go back here to make this obvious. I'm going to turn off support for arcs in the XZ and YZ plane, and we're going to set to brake at 180, and we're going to save it. So now I've set my default values. And if I go and select my parameter read program number post, and then I go click on the arc page, you'll notice that it's using the old values that were saved prior to when I set my default values. If you right click in the gray area of any one of these pages, you can then go down to import and then all pages. And I'm going to pull it from the exact same control definition I've already got open. So I'm going to select open, and now it'll say control import, select the type and post key, and we want to import our values from the defaults. So I'll select OK, and it will automatically make that configuration change for me. So I'll save that, and now all of my settings in this post match my default settings. Okay, so far so good. And this is okay. So I'm going to do a replace. And that gets us our new post. And I'll start by just posting out right from the get-go. So these are all the default values. And here's the output we're getting. So it's program number 222. We've got the tool list turned on. So we're getting all that data output from the tool list. And we get all the rest of our output. If I go and I change the program number here, and I repost, nothing's going to change. And the reason nothing's going to change is that the program number is saved into each operation when the operation is created. And yes, we have the option to select the operations, go in and do edit selected operations, and change program number. So we can change the program number here, and then we can repost and we'll see the change occur. But I had a customer that requested and said, well, I just want to be able to change the number in the dialog and have it work. I said, okay, I think we can do that. So if we look at the machine group properties, this program number here in the tool settings dialog is stored somewhere. It's stored in a parameter value. And so if we go look, if we go look at the parameters, machine group parameters are on page 272. Okay, so we got our post and machine group parameters. So you'll see here the first section, machine group properties visual reference, shows screen captures of all the different dialogues annotated with the parameter numbers. The second section, list of parameters on page 277, lists all the parameters by group and number. You'll notice over here, see capturing machine group parameters on page 33 to learn more about capturing the parameter values in your post. So there's a good bit of information there that talks about how to add code to capture and output and use parameter values. Visual reference. This is one of several visual reference sections in this document. Most of the fields shown in the following pages use parameters to store their values, but the values for some fields are available as predefined variables or even directly in the NCI G-code. Use the following color key to determine the type of value. Red labels indicate parameter numbers. Blue labels indicate predefined variable names. Green labels indicate NCI G-codes. Some fields are available as both parameters and predefined variables. In these cases, you can use whichever method is most convenient. Typically, this will be the predefined variable. So if we look here on the Files tab for the machine group properties, you can see that the group name is available as parameter 19,246. The toolpath directory string is available as 19106, and the group comment is 19111. Now, being able to store and retrieve data gives you flexibility and freedom to do whatever you want with the data. So if you want to do something special with the group comment, you can store data there and you can retrieve it in your post. You'll notice that we have parameters down here that get output. So the machine name is NCIG code 1051. The operation comments are 1008. 1053 is the group name, and 1052 is group comment. So the comments at the bottom of the tab are available directly from the NCI file rather than as parameters. On the Tool Settings tab, Machine Group Properties, you can see here program number, which is the one we are interested in, is 19113. You can see that the feed calculation setting, whether it's set to from tool, from material, from defaults, user defined, is stored in 19114. Maybe you have a special tool library, and that tool library has specific feeds saved with tools that you want to only use. And Johnny on second shift keeps setting it to from material and screwing something up. So maybe you want to add some logic to your post to check the value of this. Or if it's based on from material, you want to run a special function to calculate it and see if it's in the normal range that you use, and if not, report an error. All of these values are available. So here you've got just feed on arc move. You can check and see whether this checkbox is turned on or not. And if it is enabled, you can see what the value is. A toolpath configuration. Assign tool number sequentially. You can check and see whether that box is turned on or off. Warn of duplicate tool numbers. Now a checkbox is typically a 0 or 1 value. And it is 0 if it's unchecked and 1 if it's checked. Sequence number. You notice the start number here, SEQNO, and then the increment, SEQINC. So these are both predefined variables that hold the value of the start sequence number and the sequence increment. The type of tool material is stored as 19123. And if we're in lathe, the tool clearance values are stored as parameters as well. By the way, these tool clearance is the reason you should always define stock and chuck if you're in lathe. Okay, stock setup. We also get parameters that describe these values. So you can see the OD X value and Y value is STCK, WDTH, so stock width, stock height, and stock thickness. Those values are available. So maybe we want to capture the size of the block and output it to the NC code. Okay, we can do that by accessing either the parameter number itself or the numeric parameter value. Okay, but we were interested here in 19113. So that's the parameter we want to use. If we go back to the top of the section here, let's go read capturing machine group parameters. Well, there was a section here that talked about capturing them. Okay, so it's not in this document then. That's what it is. Capturing machine group parameters. Yeah, so that must be an old reference because they've got the new guide, working with tool and operation parameters. Yeah. So this is the new guide. Looks like there's just a mistake in that documentation. So working with machine definition, control definition, and machine group parameters. Mastercam includes a group of functions that are designed to let you get parameter values from your machine definition, control definition, or machine group. For each type of parameter, there is a specific query function. So this is the new stuff. Yeah, this is the new stuff. Let's go look at, there we go, the X9 guide. Yeah, so we'll start up near the top because that's a better place to start. And we've been going for quite a bit here. So let's do this. Let's take our mid-class break anyway. Let's go ahead and take our break, and we'll split the video and we'll come back and learn more about capturing operation and toolpath group and machine parameters.